Okay, here we go. We are here for the classwork for 9.5, page 625, number 1 through 25 odd. I've picked out a couple problems to go over with you. And again, I think you'll find that it's a pretty easy classwork. So let's take a look at number 5. Number 5 says, a square has an area of 36 meters squared. If the area is doubled, what happens to the side length? Okay, so the area equals 36 meters squared for this particular square. And then they say what happens if we double it, and so then the area would be 72 meters squared. Well, I can show you the slow way and then how we could have answered this in about 2 seconds. The concept here is that if the area is 36, well, what if this is a square? So what must the dimensions be? Just the square root of 36. So that means the side lengths of the original were 6. Okay? Square root of 36, so the sides were just 6 meters. So if I doubled the area to 72 and I had another square here, well, then what would those side lengths be? Well, they would be the square root of 72. And let's see, the square root of 72 is actually the square root of 36 times the square root of 2. And so we get 6 square root 2. So while the dimensions here were 6, the dimensions here are 6 square root 2. And so you can see what happened. When I doubled the area, this goes back to question number 5 on the homework. When I doubled the area, I changed the side length by square root 2. Okay? And so I kind of worked a way to demonstrate how this was the case with the specific numbers. But if I saw this problem, I'm taking a quiz or a test, and I'm confident, then I can just say, well, if I double my area, if area is times 2, then the dimensions are just the square root of that. Okay? So I'm just summarizing that outside of this problem. So again, no matter what this dimension was, if this was the area was 50,000 and we doubled it, well, the side length is going to change by the square root of 2. Or if the area was 36 and we tripled it, then the change to the side length would be square root of 3. Okay, so whatever the area changes by, say a, then the dimensions is the square root of a. So keep that in mind and make sure you read carefully when you do these problems, whether it's the side length changing or the area changing. Okay, let's try number 7 now. Number 7. A restaurant has a weekly ad in a local newspaper that's 2 inches wide and 4 inches high. It costs $36.75 per week. The cost of each ad is based on its area. If the owner of the restaurant decides to double the width and the height of the ad, how much will the new ad cost? Okay, there's actually not as much math in here implied as you might think. You've got an ad, and it just says that they're going to double the dimensions. You know, it gives you the dimensions, but we don't really care. If you double the dimensions, what is that going to do to the area? Well, if your change in dimension is a, then your change in area is a squared. So that means it's going to quadruple the size of the ad. So the ad is getting 4 times bigger. And so if the ad's getting 4 times bigger and it says you pay for the ad by its area, that means the cost of the ad is going to be 4 times more. So if the original cost of the ad was $36.75, then you're just going to say, well, now I have to pay 4 times as much because I pay by the area. And the area has not, I doubled the size, but that means the area is increased by 4. Okay, so the answer is just 4 times this amount. $36.75 times 4 comes out to $147 even. Okay, so notice, if you double the area, which is what happened here, double the dimensions, then the area becomes that number squared times bigger. So that means we're going to have to pay 4 times as much for that ad. If the ad had been priced according to perimeter and not area, which would be weird, but say it was, then if you double it, then the price would have just doubled. Okay, let's look at number 9. So let me do a slightly better job here. We need to, number 5 was, the final answer was square root of 2, and this one would be $147. Okay, we're going to do number 9. Number 9 says the base of a parallelogram is multiplied by 2/3. And the instructions say find the effect of the area. Okay, so if I've got a parallelogram, okay, who's got a certain base and height, okay, and I'm just going to do this slow, but the answer is 2 seconds of thought but I'm going to explain it. So we've got a parallelogram that would be base times height. Well, what happens if I come and it says I multiply the base by 2/3? Well, so now my area is 2/3 base times height. So notice if I multiply the base by 2/3, the area has now been multiplied by 2/3. So that's my answer, 2/3. Okay. You might say, wait a minute, it's area, and I thought you were supposed to square it, so how come it's not 4/9? Well, notice it didn't say both dimensions changed by 2/3. Only one dimension changed by 2/3. So that's like why I think there was question number 3 on the homework. If only one dimension changes, then that one change is what has happened to the area. Because yeah, you can see if both dimensions had changed by 2/3, I would have multiplied 2/3 by 2/3 and gotten the square 4/9. But again, I'm doing this as an example because if only one dimension changes, then that's the only change that's going to take place. So again, tricky in the details, but not necessarily the calculations. All right, we're going to do 13. Number 13. Now, 11 and 13, you can look at those and think, wow, these are really complicated, but I'm doing this as an example to show, no, it's not complicated. You don't even have to use the information they gave you. Just like number 7, the dimensions of that ad didn't matter at all. All that mattered was, well, how much bigger was it getting? So 13 says, the instructions say we're supposed to explain the change on the perimeter and the area of the given figure. Okay, so number 13, it says a square has vertices, and it gives you these vertices. I'm not even going to read them because it says all that matters is if you triple the area, what's going to happen to the side length? Okay, if you triple the area, what's going to happen to the side length? All right, well, this is just like number 5, where we doubled the area, and so the side length changed by the square root of doubling, which was the square root of 2. So number 13, if we triple the area, then that means the side length are going to be, again, I'm tripling the area, so that means the side length are going to change by the square root of 3. Okay, and that's it. Okay, it's that simple. You don't have to graph it, you don't have to calculate anything. All that matters is the scaling of change. And so if I'm tripling the area, notice it's the reverse of this one. I'm not tripling the side lengths. I'm tripling the area, then that means the side lengths must be changing by the square root of 3. So once it's explained, you can see there's not a lot of calculations going on here, and you're going to get through this classwork very quickly. Though check your answers because you don't want to do it very quickly wrong. And the last one I want to talk about is number 17. It says we're describing the change on the area of the given figure. 17 says the base of a rectangle is multiplied by 4 and the height is multiplied by 7. Okay, and again, I'll explain it, but you could have the answer in just a second. Let's just say we have the base and the height. All right, so our standard area is base and height, but it just said that my base is multiplied by 4 and my height by 7. Well, you can look right there. What's my new area? 7h times 4b. So my new area is 28bh. So how much bigger did it get? Times 28. Where did that number come from? The accumulative change of both dimensions. If one dimension had been changed, it would have gotten 4 times bigger. If just this one had changed, it would have gotten 7 times bigger. Because they both got changed, it's going to get 28 times bigger. Okay? So again, I didn't have to draw all that to get that answer. Once you know, again, you can get to that. You can calculate it very quickly. If the dimensions had changed 2 and 3, then it would have been 6 times bigger. If it had changed by 4 and 5, it would have been a 20 times change. Okay? But I just kind of show you the reasoning that goes behind the answer. Okay, if you want clarification on any of those, or there's another one that you're not sure of, please Zoom chat me. Encourage you not to give up. You can do it. I'd love to hear from you, even if it's just for a few. It doesn't have to be a long talk. Sometimes I've talked to people and helped them with one question, and it's lasted 2 minutes. So don't hesitate if you're confused at all. You can definitely do this and do it well.
All right, take care.